Hi, how's it going? Welcome to Code with Z. In today's video, we gotta go from this linked list that we have here to this one. Why? Well, because that's what LeetCode 82 remove duplicates from sorted list part 2 is asking us to do. As you can see, it says, given the head of a sorted linked list, meaning this node that we have here, this is gonna be the head, delete all nodes that have duplicate numbers. As you can see, this is why we went from this to this. The number 3 and the number 4 have duplicates, so you have to delete all of the occurrences of 3 and 4. And therefore we go from 1 to 2 to 5. 1 to 5. And then as you can see, the question says we have to only leave distinct numbers from the original list, and at the end we have to return the linked list sorted as well. As you can see, this is sorted. Alright, let's see how we can solve this. Let me bring this down here. The approach that we're going to use is going to be pretty simple, and I'll visualize the whole process. Since we need to remove duplicates, we have to compare these numbers that we have here. So for example, if we start from this position, we have to compare 1 with 2, or like we're going to compare 2 with 3, or like we're going to compare 3 with 3. And if we have a duplicate, we have to say remove this entirely. So when I'm comparing 3 to check if there's another 3, I have to be able to remove this node that I'm currently pointing to as well. So we need two variables. One variable is going to be pointing to the current node that we are exploring, and one variable is going to be pointing to the node before it, prior to it. So if we had to actually remove all of this, we can be like, okay, we don't want this, but we need to know what the previous node was. So we have to have a pointer that's pointing to our previous node and a pointer that's pointing to our current node. Now, this is just a short explanation because I'll visualize the whole process, but for starting this whole thing, we have to have a dummy node. We're going to use this dummy node because we're going to basically fuse it here, like so. As you can see, we just added our dummy node to the existing linked list that we had previously, as you can see. And the reason is this dummy node is going to save us from a ton of edge cases. For example, if the duplicate was actually the head of our linked list, we're going to have to deal with an edge case. But if we have a dummy node in the beginning, we don't have to deal with that. All right. So this is going to be our dummy node. And as you remember, I said we're going to need a variable called previous and a variable called current. These are going to be our two pointers. This is the only thing that we need because current is going to be pointing to the current node that we have here, and we're going to compare its value with the next value, and previous is going to keep track of what the correct previous node is. So let me show you how we actually do this. So we're looking for duplicates. So you have to get this value here and compare it with the next value. As you can see, we're getting the value that current is pointing to, and we're comparing it to the value of the node that's next to current. We're going to ask, is 1 equal to 2? Not really. So we're going to be like, awesome. We're not going to do anything. The only thing that we have to do is to move forward in this linked list because we have to loop through each node and remove the duplicates, right? And we just realized this node is okay. So we're going to be like, okay, previous should be equal to current, and then current should be equal to current.next. We basically just went one node ahead. Now current is pointing to 2. As you can see, we're going to get this value. We're going to say, is the value of the node that current is pointing to equal to the node after it? So is 2 equal to 3? Not really. So we're going to be like, awesome. Let's move one node ahead. Let's do that. Previous is going to be equal to current, and then current is going to be equal to current.next. Basically, we just moved ahead by one node. Then we're going to be like, let's get this value and compare it with the value next to it. We're going to ask, is 3 equal to 3? Well, would you look at that? It is. So we're going to be like, okay, because we have a duplicate, we're going to keep on moving current until we reach a node that its value is not going to be equal to the value next to it. Currently, the value of the current node is equal to the value of the node next to it. So we're going to keep on moving current, as you can see, and then we're going to check again. We're going to say, is the current value equal to the next value? Well, not really. So we're going to stop, and we're going to say previous should not point to 3 now because we know we have to remove this. We're going to say previous should point to the next of current, like so. The next of current is this, because remember, previous is keeping track of the correct node that we have. And because we don't want these duplicates, we're going to say previous should point to the next of current. Simple as that. And then we're going to say, okay, because we know we've already taken care of this, we're going to say current should be equal to current.next. So we moved current as well, like so. And this is basically removing this from the chain as if it didn't exist. So to recap, when we don't have a duplicate, we just move forward. When we have a duplicate, we're going to increment current as many times until we reach a node that its current value is not going to be equal to the value next to it. When we reach that position, we're going to say previous should point to the node next to current, and then we're going to increment current as well. Again, we're going to have the same thing. We're going to say, is the current number that you have here, which is 4 because this is the number that current is pointing to, is it equal to the number next to it? It is. Okay, so let's increment current until we reach a point that the current number is not equal to the number next to it. Well, let's check again. Is 4 equal to 5? It's not. So we have reached a point where current is pointing to a number that the value next to it is not equal to itself. So we're going to say, awesome, previous should point to current dot next. Previous should point to current dot next, as you can see. And again, we do this because we know previous is pointing to the correct node that we have so far. And then we're going to change its next to here. Then we're going to be like, okay, let's increment current and ignore these entirely as if they didn't exist in the beginning, like so. Now we want to grab the value of the current and compare it with the next node, but the next node doesn't exist. So we're just going to increment current, and now current is pointing to null or nothingness. So we're going to stop looping. And if you take a look, we're basically done. After our loop, we're going to say return anything that's after our dummy node. Well, anything that's after our dummy node is going to be 1, 2, 5. As you can see, well, 1, 2, 5 is basically the linked list that we saw in the beginning of the video. As you can see, 1, 2, 5, 1, 2, 5. And this is how we solve this. Now let's code this in the simplest way possible. Alrighty, let's code this together. So the first thing that we need to do, just like we saw on the slides, is going to be to define our dummy node. So this is going to be a new list node, like so. And we got this list node from the question itself. It basically defines a node for us. And then we have to fuse this dummy to the head of our linked list, like so. So dummy.next is equal to head, just like we saw on the slides. Then we have to define our two variables. We're going to say let previous be equal to dummy and let current be equal to head. So we basically have our pointers. Previous is pointing to dummy and current is pointing to head. Now we're going to say while current is not equal to null, because just like we saw on the slides, we stopped looping when current was pointing to null or nothingness. Here we have to look for duplicates. So we basically say if the number that we're currently pointing to is equal to the next number, do something. So we're going to say if current.val is equal to current.next.val. So you basically say if the current value is equal to the next value, do the following. Here we're going to say we want to keep on incrementing current as long as we have duplicates. So we're going to say while current.val is equal to current.next.val, current should be current.next. We want to keep on moving forward until we reach a point where current.val is not equal to current.next.val. And this is to, for example, if we have 25 occurrences of the number 3, we want to just move through it, right? Because we don't want them at all. So that loop is going to take care of that problem. And then when we're done, we're going to say previous.next should be equal to current.next, because we said the next of our previous node should be the next of the current node, just like we saw on the slides when we said 2 should point to 4 and then we said 2 should point to 5. Now this is going to be when we have a duplicate. If we didn't have a duplicate, so else, we're just going to say previous should be current. Simple as that, because if you remember in the beginning, we always said previous should be equal to current, and then no matter what happened, we always incremented current. So current is equal to current.next, and then this is going to be it. At the end, we're just going to return dummy.next. But there's one simple thing that we still need to do. When we're looping through our linked list, we need to make sure that current.next also exists, because we always check its next value, right? So we always check the next of the current because we want its value to check if we have duplicates. So when we loop, we always need to make sure that current.next is not equal to null as well. Then we have our other conditions. So you basically can just copy this and add it here as well, because we want to make sure that we do the comparisons only when the next node exists. Because if you remember, at the last node, we didn't compare the numbers because we knew the next node did not exist. The next was a null, so we didn't compare any numbers. Now, this is going to be all of our code. Let's run this and see if we can actually get accepted. Moment of truth. And yep, awesome. Let's see if we can actually pass all of our test cases. Drum roll, please. Just kidding. Let's see. And awesome. We got accepted. Thanks for watching. Don't forget to like and subscribe and keep on coding.